Okay, good morning, students. We have 4 topics to be discussed in week 2. The first topic, the sum of the arithmetic series. Then number 2, the arithmetic mean. Number 3, geometric sequence. And number 4, the sum of geometric series. The first topic that I'm going to discuss, we have the sum of arithmetic series. In solving the sum of arithmetic series, the formula like for example, so a the subscript 1 is equal to 4, then n is equal to 10, then d equals 6. Then the formula for solving the sum is the subscript of n is equal to n over 2, then open brace, we have 2a, the subscript of 1 plus open parenthesis, n minus 1, then close parenthesis, then multiply it by d, then close brace. Then substitute, we have the number of terms is 10, then over 2, then multiply it by, we have 2, a, the value of a, the subscript of 1 is 4. So multiply it by 4. Then plus open quantity. So n is equal to 10, then minus 1, then close parenthesis. Then the common difference is 6. Then simplify. 10 divided by 2, so we have 5. Then open brace. 4 times 2, okay, so the product is 8. Then plus, so open quantity, 10 minus 1, so we have 9. Then multiply it by 6, then close brace. Okay, so we have 5, open brace, then 8 plus, so 9 times 6 is equal to 54. Okay, then close brace. Then simplify. We have 5. Then open brace. 8 plus 4 is 62. Then multiply. 62 times 5. So we have 10, carry 1. So we have 30 plus 1, that is 31. So the sum is equal to 310. Example number 2. A, the subscript 1 is equal to 2. Then common difference equals 4. Then number of term equals 10. Then we have the formula. The formula we have is the subscript of n is equal to n over 2, then open brace, 2a, the subscript of 1, plus open parenthesis n minus 1, then multiply it by common difference. Then we have the number of terms is 10 over 2, then open brace, we have 2, the first term is 2, then plus, open parenthesis, the number of terms is 10, then minus 1, then close parenthesis, then the common difference is 4. Then simplify. So we have 10 divided by 2, so the quotient is 5. Then open brace, 2 times 2, the product is 4. Then plus 10 minus 1, so we have the difference is 9. Then 4. Okay, simplify. So we have 5, open brace, 4 plus 9 times 4. So the product is 36. Then close brace. The next, we have 5, open brace, 4 plus 6 equals 40. The next, multiply. So the sum is equal to 40 times 5. So the product is 200. So the sum is equal to 200. So our next topic, we have arithmetic mean. When three numbers form an arithmetic progression, the middle number is called the arithmetic mean between the other two. So in the sequence 2, 4, 6, 8, 4 is the arithmetic mean of between 2 and 6. Then 6 is the arithmetic mean between 4 and 8. Like for example number 1, insert 3 arithmetic means between 3 and 23. The formula in solving the arithmetic mean, so you have to solve the common difference. We use the same formula in the arithmetic sequence. So A, the subscript of n is equal to, that is A, the subscript of 1 plus open quantity n minus 1, then close quantity, so we have D. Okay, so this time, you have to solve common difference. So the first term is 23 is equal to, then we have the first term is 3, then plus the number of terms is 5, then minus 1, then close parenthesis, then we have D. Okay, solve. 23 is equal to, we have 3 plus open quantity 5 minus 1, okay, equals 4. Then we have here D. Then 23 is equal to 3 plus 4 times D, so we have 4D. Okay, then transpose. We have 23, so 3 transpose to the left side, the sign becomes negative 3, then equals 4D. So 23 minus 3, so we have 20. Then we have 4D. Then divide 4 both sides of the equation. So we have D is equal to, okay, so 20 divided by 4, so we have here 5. So the common difference is equal to 5. Then after that, insert 3 arithmetic means. Okay, we have 3 plus 5, 8. 8 plus 5, okay, we have 13. 13 plus 5, 18. 18 plus 5, 23. So, the 3 arithmetic means, okay, we have 8, 13, and 18. Now, example number 2. Insert 4 arithmetic means between 8 and 18. First, you have to solve the common difference. So we have the formula, we have here n A is equal to n, that is A, the subscript of 1 plus open quantity n minus 1, then close parenthesis D. Okay, so the last term is 18. Then the first term is 8. Then plus n is 6 minus 1, then close parenthesis. So 18 is equal to, so 8 plus 6 minus 1, so we have 5. Then D. Okay, simplify. We have 18 is equal to 8 D times 5, so we have 5D. Then after that, transpose. So we have 18, positive 8, it becomes negative 8. Then equals 5D. So negative 18 minus 8, so we have 10. Then equals 5D. Then divide 5 both sides of the equation. We have 5, then we have here 5. So 5D divided by 5, so we have D. Then 10 divided by 5, so the answer is 2. So therefore, we have the common difference is 2. Then insert 4 arithmetic means between 8 and 18. So we have here 8 plus 2, 10, plus 2, 12, plus 2, 14, plus 2, 16, then plus 2, 18. So, the 4 arithmetic means between 8 and 18 is 10, 12, 14, and 16. Okay, our next topic, we have geometric sequence. Geometric sequence or progression is a sequence in which each term is obtained by multiplying the preceding term by a constant number called the common ratio or R. The formula in solving the geometric sequence is A, the subscript of n equals A, the subscript of 1, multiply it by R, raise the power of n minus 1, where A, the subscript of 1, stands for the first term. A, the subscript of n, stands for the last term. Then n stands for the number of terms. Then R stands for constant ratio. Okay, example number 1. Find the 10th term of the geometric sequence 2, 4, 8, and so on. Okay, so the first term is 2. And common ratio is 2. Then we have the number of terms is 10. The formula in finding the geometric sequence, so A, the subscript of n, is equal to A, the subscript 1, then R raised the power of n minus 1. Okay, simplify. Now we have A, the subscript of 1, is equal to 2. Then multiply it by R, common ratio is 2, then raise the power of 10 minus 1. Okay, so we have 2 open quantity, 2 raised the power of 10 minus 1, we have 9. So we have 2. So multiply by itself 9 times. Okay, so we have 2 times 2 times 2 times 2 times 2 times 2. So we have the product is 512. Then we have the last term is equal to 512, multiply it by 2, so we have 1024. Okay, this is now the last term in the geometric sequence. Example number 2. Okay, so we have A, the subscript 1 equals 3. Then common ratio equals 5. Then the number of terms equals 7. Okay, the formula we have here, A, the subscript of n is equal to A, the subscript of 1, multiply it by r, raise the power of n minus 1. Okay, so we have simplified. The first term is 3. Okay, then we have r, common ratio is 5. Then raise the power of n. N is equal to 7. So 5 raise the power of 7 minus 1. Then close quantity. Okay, so we have 3 open quantity. So 5, 7 minus 1, we have 6. So we have here 5 raise the power of 6. Then simplify. Okay, we have open parenthesis. So multiply by itself. Okay, 5, 6 times. So the product is equal to 15,625. Then after that, multiply. 15,625, multiply it by 3. So the product is 46,875. Okay, so this is now the last term of the geometric sequence. The last topic for week 2, the sum of geometric series. In solving the sum of geometric series, we have the formula. The formula is the subscript of n equals a the subscript of 1 minus a the subscript of 1, multiply it by r. Then raise the power of n over 1 minus r. Where is the subscript of n stands for the sum. Then a, the subscript of 1, stands for the first term. Then n stands for the number of terms. Then r stands for the constant ratio. Okay, example number 1. Find the sum of the 7 terms of a geometric series. 3 plus 6 plus 12 plus 24. Then the first term equals 3. Then the number of terms, 7. Then we have common ratio is 2. Okay, the formula in solving the sum of the geometric series is the subscript of n equals a, the subscript 1, then minus a, the subscript of 1, multiply it by constant ratio, raise the power of n, then over 1 minus r. Then simplify. The first term is 3, then minus 3, then multiply it by, we have constant ratio is 2, then raise the power of 7. then over 1 minus 2. Okay, so we have 3 minus 3 open quantity. So multiply by itself 7 times. So the product is 128. Close quantity. Then divide it by, we have 1 minus 2. Okay, then we have 3 minus multiply. So 128 multiply it by 3. So the product is 384 over. So we have 1 minus 2, that is negative 1. Positive 3 minus 384. So we have here negative 381. Divide it by negative 1. So the final answer, the sum of the geometric series is equal to negative 381. Divide it by negative 1. So the answer is positive 381. So this is now the sum of the 7th term of the geometric series. Okay, example number 2. Find the sum of the first 10 terms of geometric series. 3 plus 6 plus 12 plus 24. Then we have A, the subscript 1 equals 3. Then N equals 10. Then R equals 2. Then the formula, we have A is the subscript of N equals A the subscript 1 minus A the subscript of 1. Then multiply it by R, raise the power of N. Then divide it by 1 minus R. Okay, so we have substitute. The first term is 3. Then we have 3, multiply it by, the ratio is 2, raise the power of 10. Then divide it by 1 minus 2. Then we have here 3 minus 3, open quantity, 2 raise the power of 10, then close quantity. So meaning, multiply by itself 10 times. So we have here 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. 128 times 2, 256. 256 times 2, 512. Then 512 times 2, so we have 1,024. Okay, so we have 1,024. Then over negative 1. Okay, we have 3 minus, okay, 1,024 multiply it by 3, so the product is 3,072. Then over negative 1. So 3 minus 3,072 equals 3,069. Negative 1. Then we have negative 3,069 over negative 1. So divide. Negative 3,069, divide it by negative 1. So the answer is positive 3,069. So this is now the sum of the first 10 terms of the geometric series. 3 plus 6 plus 12 plus 24. Our activity for week 2. So write your answer in the yellow pad paper. So we have number 1, find the sum of the infinity of the geometric progression with the first term, and the common ratio is 1/2. Then number 2, the sum to infinity of geometric progression is 4 times the first term. Then find the common ratio. Then we have the last, the sum of the infinity of the geometric progression is twice the sum of the first 2 terms. Find positive values of the common ratio.